welcome to another exciting Dagster Deep Dive. This one will be around transforming prompt spaghetti into production ready LLM engineering with declarative frameworks, DSPy and Dagster. And like the flow that a lot of us have experienced, whether we have been experimenting or building with LLM applications or data scientists doing so-called traditional machine learning, is your demo or proof of concept works great in your notebook or locally, and you look like a genius, everybody's impressed, and you have this solution that's really going to solve a lot of problems and deliver value. And then you go through the slog of turning it into a deployable script, and you're adding logging, error handling, and maybe some light orchestration if you're not using Dagster. And then comes the managing in production and the headache that comes from a lack of proper orchestration and observability. And that reactivity is so common for engineers, data or otherwise, where you need to babysit your production instance and you're stuck in this reactive firefighting loop as opposed to doing what we love, building new features and optimizing performance and refactoring our code. And the way that most engineers are writing LLM code currently is hacking scripts together. And as we've discovered that prompts are the main point of leverage for LLM performance. And the landscape is still having a tough time getting a handle on what's the best practices around building LLM software that's maintainable, scalable, and performant. And the main issue is having your prompt as a wall of text like here. And when your prompt is like this, it falls outside of the software developer lifecycle. You lack type annotations, and it doesn't fit into your tooling that you use on a daily basis like linters. And it's so much harder to test and debug, and you realize you have a problem with it. And like, from my personal POV, it just looks dusty and not how like production code should look.
Yeah, I will say I've written a fair amount of code that looks just like that past one. So I'm excited to see how DSPy differs.
Yeah, I mean, we all do, but like we should try not to. But like at the end of the day, writing LLM code is very similar to doing data engineering. And like what we're doing is ultimately writing software. And so you have data in, data out, transformations, managing state, interacting with APIs and external systems, and of course, testing and managing data quality. And the tools and frameworks that people are developing in the ecosystem of data engineering and software development more broadly means that you don't have to reinvent the wheel when it comes to orchestration and managing your production workloads. And if you look at a lot of these so-called agentic frameworks, they often have a embedded orchestration component. So loops, logic gates, parameterized config, retries, and so on. And we already have some great orchestration frameworks that can handle a lot of this production complexity. And they've been in development for Dagster about like 7 years now, and Airflow has been around for like 15 years. So a lot of the edge cases have been ironed out, and you don't have to reinvent the wheel.
Yeah, I will say even on social media, I'm seeing a lot of people talk about durable workflows and just like pipelines in general. And it's funny that these like concepts are being reinvented or rediscovered when it's kind of like just what data engineers have been doing for the past decade. So it's good to leverage the existing tools when you can.
Yeah, I feel like there's a common trope that the so-called like 10x engineers fall into, where they get nerd sniped into like building their own framework for something instead of using something off the shelf. And I feel like in most use cases, the off the shelf solution can work in your favor, and you don't need to reinvent the wheel. But so building LLM applications doesn't have to suck. And when you get out of the proof of concept stage for building an LLM app, you quickly run into the complexity that causes your brittle scripts and hard-coded prompts to become a challenge to monitor, debug, and enhance. Additionally, new models come out all the time, and you don't want to waste cycles on making sure your prompts are optimized and can take advantage of the power of these new models. And in my opinion, building applications for LLMs is data science. And you want to have an iterative flow to monitor, optimize, and evaluate in a programmatic way. And orchestrators bring the production ready capabilities to your LLM pipelines. So you can take advantage of that. Which brings us to DSPy. So DSPy is a declarative framework for building LLM development. And it solves so many problems in the current state of AI development that I mentioned. And I've kicked the tires on many of the leading LLM and agentic frameworks and found them wanting, whether they're missing a key orchestration and observability elements, or if they are there, they're half baked. And the code for most of them just looks ugly and covered in Cheeto dust. And there's this talk by Krista Apsel-Ong and Omar Khattab. That is a fantastic introduction to DSPy. We'll link it in the comments here. And like they lay the great groundwork of like why they built this and how it solves a lot of these problems. And we have a code example here where it shows a DSPy signature, which outlines how the LLM is supposed to interact with your code, and it figures out the prompt for you and you don't have to write it yourself. So the main abstractions in DSPy are the signature, which is the specification of input-output behavior, so question or answer, or context question and answer. And you define what a module should do without specifying how. And you can include type hints and descriptions for better prompting. Modules are the building blocks that wrap language model calls. And the common modules are predict, where you're doing a basic prediction, chain of thought, which adds reasoning before answering, react, which interweaves reasoning and actions, and program of thought, which generates and executes code. And the optimizer is probably the killer feature of DSPy. And it automatically optimizes prompts and module parameters, so you can get some embedded performance without having to think about it too far. And if you're doing optimization, you need to have metrics. So those metrics feed into the optimization flow to make everything work better. And what's cool about combining these two frameworks of Dagster and DSPy is they speak the same language. Both make heavy use of Pydantic models. So when you define your data contracts once, and it flows seamlessly through your entire pipeline from data prep, LLM reasoning to downstream actions. So you don't have to write the additional glue code or type conversion. It's just pure Python end to end. And you wouldn't build a data pipeline without orchestration, even though some people do. But why would you build an LLM pipeline without it? And DSPy makes your prompts intelligent and optimizable. Dagster makes them reliable, observable, and production ready. And at Dagster, of course, we pioneered the asset-centric approach, where the output or your data asset you create is more important than the process itself. And when you focus on assets, you get improved visibility into how they are related to each other, testing, whether they work as intended locally or in production. You can leverage resources like databases or data warehouse, so you can abstract that compute and storage away from each other, and you gain better performance and monitoring after you deploy to production. And the graph is still the best model for how your data platform maps to your business. And LLM applications are just another component to your data platform, and it often consumes data assets from it. So it should be incorporated into your existing orchestration framework, whether it's Dagster or Airflow. And we also launched components this year, which is our take on declarative pipeline setup using metadata. And I've been a low-code hater for some time now. And because mostly the process of modeling your business requirements to some sort of low-code interface often fails when you run into an edge case, which happens in like 95% of business processes. And code can model those extremely well. But doing everything code first presents an accessibility problem, as most people are not trained engineers and they don't want to be. So components is a way to expose just what people need to build pipelines while adhering to software engineering best practices and your kind of hairy business logic. And of course, they're versioned and reusable and shareable. So what if you never had to write a prompt again? This is what DSPy boldly questions us. And like I mentioned earlier, prompts are the main point of leverage for developing LLM apps. And once you get out of the proof of concept stage for an LLM project, you can it's not uncommon to have tons of prompt files that are hundreds or thousands of lines long. And managing those and debugging and staying on top of those can eat up a ton of cycles and isn't fun work and can take the wind out of your sails. And this prompt soup is the main challenge that DSPy solves for. And what you do at a high level is declare what you want and let the system figure out how to achieve that. And using DSPy feels like a breath of fresh air. So we can go back to building software like the days of old. And as you can see here in the DSPy signature here on the right, there is no prompt. You just define some type safe inputs and outputs, and DSPy does most of the work for you. So you don't have to manage the output format or system prompts or anything like that. So it's a lot more clean and it's easier to test, and it's a lot more scalable as well. And like I mentioned, my favorite part of DSPy is the automatic optimization. So the system can optimize itself automatically, and the code to do it is pretty simple. Whereas if you wanted to like hand roll an optimizer, it would be pretty hairy and it would be difficult for others to debug and manage, which like ultimately we should be writing software that other people can understand and leverage and improve. And we will, for the demo project, we use the New York Times connection. And our previous head of DevRel, Pedram Navid, did a long project where he ran every model available right now through this process to find out which one was optimized the best. And we'll share the link to that later.
Yeah. And another thing with DSPy that's really cool, and it kind of helped do this like evaluation of model performance, is that you can swap out between LLM providers like OpenAI and Anthropic just by choosing the model, and you don't have to write that code or use like a specific client to connect to the different services. That's all abstracted away for you, which is really nice.
Yeah, it makes it really easy, like Colton said, to just swap things out because they use the same abstractions for interacting with. I think they base it off the OpenAI API, and everything follows that same structure. And of course, like as we know with managing or writing code or software, the challenge isn't in the initial writing of the code, it's managing it over time when it's in production. And having an orchestration framework in place makes this process a lot more stable, auditable, and recoverable when something goes wrong. And the problems that you run into in production or when you're scaling are often an afterthought when you're in the development or proof of concept stage. You also don't want to be that often senior guy that's a Debbie Downer poo-pooing every new idea or data product. So your tooling should support local development, testing, and those day two operations to minimize tech debt and tribal knowledge. And we used components in this project to abstract away a lot of the underlying both DSPy and Dagster logic. So if somebody that is non-technical wanted to like create a new pipeline, they could just type in what they needed to, these like 10 lines or so here, and it gives them everything they need that is adhered to software engineering and Dagster best practices. So for the project, we went with the New York Times connections puzzle, which is fitting because if there's one thing I know about data, it's about love and it's about connections. And with that in mind, you can follow along. The link will be in the comments, but we'll go over the basics of solving the puzzle, how we model the game with DSPy, and how we map those interactions to Dagster abstractions, and the optimization loop that DSPy offers. Here's the link. So the connections game, for those that are unfamiliar, there's four distinct groups for 4 words each, linked by a common category, and each word belongs to only one group. The categories are hidden, and they range from straightforward to highly abstract, depending on the difficulty of the puzzle. And some words, they try to trick you by filling into multiple categories. So you need to be thoughtful in your approach when labeling them. And players are only allowed a maximum of 4 incorrect guesses, so you can't brute force the thing.
Yeah. In that screenshot you saw on the right, so you have like that matrix, like 4x4 of words, and you're trying to categorize those. But there can be often a lot of tricky, like false positives where something that might seem obvious, like Kansas, Arizona, Montana. Like you could say it's like US states, Utah, but they try to get you, and that isn't actually the category. And there's actually something a little bit more obscure. So the objective of this code is to come up with those categories for the words and get it within the 4 guesses that you're allowed to have.
And the problem is well suited to LLMs, like Colton was saying, because it's difficult to model as traditional code, and it's a language problem of trying to guess words. And because the state of the game and the entities involved in it can be modeled relatively cleanly with DSPy. And finally, since it's a game, we have clean and correct evaluation data, which is super useful for evaluations and optimizations. And this is the asset graph that we're going to build. And as you can see, it looks pretty simple. But if you were to look at the code and like try to model in your head what is happening during debugging and development, you would be wasting a lot of like brain space trying to keep that in your head, which is like a core value proposition of Dagster, of course. I'll switch to my cursor browser so we can go through the code.
Cool. Could you zoom in a little bit more? Yeah.
Yeah. How's this?
Yeah, it looks great.
All right. So if you want to follow along, it's in the examples repo in the main Dagster project. And so for the DSPy modules, we'll go over the puzzle. So whenever you're working with DSPy, you're often starting with data classes. So this is how we set the difficulty for the different puzzles. This is the puzzle group. This is like what a complete puzzle looks like. This is like the game state. And as you can see with these classes, they stack on top of each other. So you're able to model that complexity relatively cleanly while having everything connected in one state. And then you have the create game state, loading them from CSVs and converting to puzzle objects.
And I think like the game data we got from Kaggle, right?
Yeah, we in the repo we have the sample data set from this, but the original data was sourced from Kaggle. And then we set up the games logic here. And as you can see here, this is all just standard Python, so nothing crazy. And when we go to the solver part, this is where the DSPy stuff kicks in. So we have the game rules here, which is a simple prompt on like how it works. And then we're using a DSPy module that leverages a chain of thought for the rules, available words, historical feedback, what guess it's on to return a guess. And then this forward method creates a game state and iterates through the game to make sure that the game isn't finished, and it goes through the guess project, or it goes through the guess process. And this predict method in DSPy is where the chain of thought happens. And we also add a logging process here. And what's really useful about DSPy is it stores the logging that you do. For example, during a guess here, you can send, like in the DSPy state, it will tell you if you wanted to log it, like what the prompt was that went into it and the thinking process and the results. So it's really helpful from an auditability perspective.
Could we go back and show how the classes that we're using to model the game get referenced in the actual DSPy code? So under, was it puzzle, where we have all those data classes?
Yeah.
And if you scroll up some to where the data classes are actually defined. Wait, maybe that wasn't in this file. Oh yeah, it is here. So these like game state and like puzzle classes end up getting referenced in the DSPy code, and they are used to get like the semantic like representation of like that's used in the prompt. So like those attributes, like the names of the attributes, the types of the attributes, all of that is like meaningful in DSPy code, right? Where it then tries to like formulate a prompt to send to the LLM. Is that correct? Am I missing something?
No, that's like bang on what's happening. And I think their logo is a puzzle itself, where like 4 pieces are interconnected together. And I think that's like a great representation of what happens, because you start with the data classes, then you move on into the logic, and then you incorporate the DSPy abstractions. So everything builds on top of each other. And then moving on to the Dagster components side of things. So in the connections model builder, this is building the modules used in this process. And this is what we use for the component. And here is the asset factory or component. Sorry for using the legacy term for that. But for example, for the baseline model asset, we configure the DSPy resource. We create the baseline module for the connection solver. We save that model, and we do some logging metadata for all the process here. And then for the optimization, for example, we go through the puzzle process. We have our eval test over here. And then we call the DSPy evaluate process that takes in the evaluation data set, the metric, and the number of threads. And it does all of the heavy lifting for you.
Yeah,
and I know some of this code. Oh,
yeah, I'll interject here and say the advantage of using Dagster in this context is, the body of these asset functions here is like the actual execution that's happening with DSPy. So when you're running the evaluation or trying to solve the puzzle, but one of the key benefits of using Dagster is tracking metadata and being able to observe like the differences between each run of these like puzzle solves. So you can see we're like building up this like dictionary of metadata that then gets emitted in the asset, and that gets exposed through the Dagster UI. So instead of just like running your code over and over, your DSPy code, and just kind of like looking at the results there, you get to keep a history of everything that's run in the Dagster UI by modeling it this way.
That is a good segue to going into the UI. Like I mentioned, we have our asset graph that pulls the data in. It creates the base model here, and the evaluation step. We can see when I ran this last night, I used, I think, the Gemini, like their weakest Gemini model. And then this morning I ran with the good one, and we had some improved success metrics over here. Yeah, the base Gemini model does not perform well. And then we have the optimized asset here if we want to look at the logs. So it's using this optimization method, and we are reporting all the helpful metadata here and run config, what model we're using. And for the optimized step, we're able to see the success rate, the numbers evaluated. And during this process, it elevates the optimized model to like the production model. So you get that sense of moving a model from like development to production, which is pretty handy. Yeah, so back to the slides. We'll skip through here. And the full results can be found on Pedram's website. And like I mentioned, he went through pretty much every single model that's available right now. I was kind of shocked to see how expensive Grok was for this, but I don't know what I was expecting there. But it's interesting to see that when you look at different models, they have like different performance, and some have like a higher rate of optimized improvement using DSPy, and some work better out of the box. Like the Sonnet, I think, had the biggest improvement here. Or no, Grok 3 did.
One thing I didn't entirely follow when we're looking at like this optimized versus baseline. So that's a feature of DSPy where it can kind of iterate on the prompt that it's generating to get better results. Is that right? So like we've modeled the game and kind of like our objective, and it's trying to find the best way to do that for a given model.
Yeah, since it uses that like chain of thought signature, during the evaluation process, it provided you have like plenty of data, which is why a game is great for this. It'll iterate through using different prompts like internal to DSPy to find the one that performs the best. So I think you'd risk some overfitting here, but for something like this with a game where it's like pretty objective on the input and output, it works really well. I'd be curious to see how DSPy performs when you're running with more of like a subjective evaluation process. Like if you were to do writing or some other process like that. But yeah, so in summary, when you combine DSPy and Dagster, you get automatic prompt optimization, production-ready pipelines, full model lineage, continuous evaluation, and self-healing systems. And the key takeaway is you can step away from writing these big prompt files, and you can let the system work for you. And you can use Dagster to handle the production orchestration and observability. And you don't have to accept poor performance anymore. You can set benchmarks and take advantage of some of the really smart people out there that are building these frameworks to make it easier for you to develop production-ready code. And with that in mind, if you have any questions, now would be a great time to use the Q&A. And for those of you that don't know, we recently released Compass, which is our AI data analyst agent. And we have a demo instance on our community Slack if you want to see how it works. The link will be in the chat. And we'll also be at AWS reInvent at the beginning of December. So if you're there, make sure you stop by the booth and say hi, and you can get a Data Wrangler hat. And I believe our new ebook will be featured
that's right.
there.
Yeah, we'll have a
Colton,
new
you
book
want to talk
available.
about that?
Sure, yeah. So Dennis Hume, one of our team members, has been working on a book called Scaling Data Teams, and it talks about how you can do data engineering or build a data platform with various sizes of organizations. So like a one-man team, a five-man team, all the way up to like a large Fortune 500 company who may have 20 or 100 people all dedicated to building a data platform. It's really cool. It'll be available on our website shortly. And then also physical copies will be available at the conferences that we go to. Awesome. Well, thanks so much. Yeah, that was really insightful. I'm going to poke around the code base a bit more to learn more about DSPy, but I totally see the benefit, especially for people who are more comfortable with software engineering and working in Python, to do this over just building a huge string prompt embedded in your code.
Yeah, I think it's kind of analogous to how the development process, if you're using vibe coding, if you kind of let the vibe coding get away from you, eventually you're going to end up in a situation where you'll have to call some real engineers to come in and fix the slop. Whereas if use it strategically and focus on like specific modules and review as you're developing and testing, you'll get a lot better results. Because I know that, I don't know, sometimes it's fun to just create a new branch and let Cursor or Claude code go wild, but that often doesn't save any time and is a headache to unwind.
Yeah, we didn't even talk about the testability of DSPy, but yeah, that's another huge benefit of having actual code. You get to use all of the tooling around Python that exists out there. Cool. Well, I think that's it. I answered one question that was in the Q&A, but I don't see any others. But yeah, thanks everybody for joining. Any final words, Alex?
Yeah, thanks for joining. And I would encourage you to check out our examples in our docs where this project can be found. And we have a ton of different applications and code and narrative that explains what you're doing and why you're doing it. which can be helpful if you're new to Dagster or trying to up your game.
Great. Thanks so much. See y'all.
Bye, guys.